find the inverse function of exponential function 2x minus 1. We are following the same step like we are following in general to find the inverse function. The step 1, f of x we write with a y, that is equal with a, and everything else we write in the way how it is, 2x minus 1, 2 in exponent x minus 1. The second step, we interchange x with a y and y with a x. So whenever is y, I write x. And whenever is x, I write y. So here is x, I write y minus 1. And the third step is solve for y. In order to solve for y, first of all, we have exponential. Here, let me convert from the exponential form into the log form according to the log, to the definition. And this I can write a log. And because here is the base, and the base goes here, 2, and x is here, goes x, and everything is equal, the exponent drops down, is y minus 1, according to the definition of the converting logs into the exponents and exponents to the logs. And now I'm adding both sides plus 1, because I want here to get rid of 1 and I want to solve for y. Just let me write y in the other side, and y is going to be equal, because plus 1 here minus 1 get rid of it, and it's just a y is equal with the log of the base 2 of x plus 1. And the last step is, instead of the y, we are writing with the denotation of the inverse function, because here was f of x, and the denotation of the inverse function would be f of minus 1 in exponent minus 1 of x is equal, everything else we write in the way how it is, with a log base 2 of x plus 1. We already found the inverse function of the exponential function f of x, that is 2 in exponent x minus 1. So inverse function is f of inverse function of a log base 2 of x plus 1. So now let's go and find the opposite. Let's find now the inverse function of g of x, then log base 2 of x plus 1. Let's see, can we find now this function here? Can that inverse be the can they be inverse of each other? First step again, as I mentioned before, instead of a g of x, we are writing a y. We are substituting for y, and here is a log 2, a log 2 of x. So everything here we write in the way how it is, so we are not making any other changes, plus 1. And now what we are doing here, we are interchanging in the step 2, we interchange x with the y and y with the x. Whenever is y, I will write x, and whenever is x, I will write y. So is equal with the log base 2 of a y plus 1. And now we are solving for y. But first of all, here let me subtract both sides by minus 1. If I'm subtracting both sides by minus 1, and x minus 1 is going to be equal with the log 2 of a y, log base 2 of y, log base 2 of y. And now we are converting from log function to exponential form according to the definition. Then here the base goes in this side, the base becomes the base for the exponent, x minus 1 in exponent x minus 1 is equal with the y. And the last step here, we are we are writing here with the we are writing with the inverse denotation, because we had the g of x. Now this the inverse denotation is going to be g of exponent minus 1 here of x is equal with the function 2 in exponent x minus 1. So we already got the function. So f of x, that was a 2x minus 1, and we got the inverse function log base 2 of x plus 1, what means it's those are the inverse of each other. And if we want to interpret it geometrically, we can interpret it this way. So f of x is in 2 in exponent x minus 1, and its inverse is a log base 2 of x plus 1. And as we see here geometrically, they are interpreted. They are symmetrical. F of x and 2x in x f of x, that is 2 in exponent x minus 1, and a log base 2 of x plus 1 are symmetrical with respect to the line y is equal with the x.